Welcome to our deep dive. We're going to be exploring the world of David Marr.
Oh, fascinating choice.
You mentioned that you're interested in how humans and AI process information.
I am, yeah.
And I think even if someone out there listening isn't a tech expert, Marr's ideas are really relevant.
Absolutely.
They're surprisingly relevant and fascinating.
Yeah.
He was working back in the 70s and 80s.
That's right.
So long before all this, AI boom that's happening.
Yeah.
But the principles behind a lot of this stuff,
Yeah.
like facial recognition and self-driving cars, they actually have roots in his theories about how we see the world.
It's amazing how much of an impact his work has had on modern AI.
Let's get into it. So who was David Marr?
Well, he was a neuroscientist, absolutely brilliant, but sadly died very young.
Oh, wow.
Only 35.
35.
Yeah.
Wow.
He was born in England, excelled at math at Cambridge.
Right.
But he wasn't satisfied with just equations. He wanted to understand how the brain, this ultimate computer, actually worked.
Okay.
And his big contribution was a framework for thinking about intelligence that applies to both brains and the machines. And he called it the tri-level hypothesis.
Tri-level hypothesis.
Yeah.
It sounds a little intimidating.
It does sound a little intimidating, but
Break it down for us. What's the core idea?
So think of it like a layer cake of intelligence.
Okay.
With three distinct layers.
Okay.
The top layer, the computational level, is all about the what.
Okay.
What's the brain or the AI trying to achieve? What's the goal of the system?
So, like, in the case of vision, the goal is to understand the 3D world from the 2D images our eyes capture.
Exactly. Now the middle layer,
the
algorithmic level, gets into the shao.
Okay.
What are the specific steps?
Right.
The processes, the representations that the brain or AI uses to achieve that goal.
Interesting. So it's not just about what it's doing, but it's like the method, the recipe it's following to get there.
Yeah.
Okay, what about the bottom layer?
That's the implementational level, the physical stuff that makes it all happen.
Okay.
So neurons in the brain, circuits in a computer chip.
Right.
Whatever's actually carrying out those processes.
So it's like Marr's saying you need to understand all three levels to truly grasp intelligence.
Yeah.
It's not just about the hardware. It's not just about the software.
Right.
It's about the purpose, the why behind it all.
Exactly.
And what I find so fascinating about him is that he didn't just theorize about this.
Right.
He actually built computational models of vision.
He did, yeah.
That tried to mimic how we see. And that was groundbreaking back then.
Absolutely. And one of his key ideas that really highlights this connection between human and artificial intelligence is the 2.5D sketch.
2.5D sketch. Okay, what's that about?
So Marr proposed that our brains don't just process flat images. We build this mental representation.
Okay.
A sketch that's not quite 2D, but not fully 3D either.
Yep.
It captures things like depth, shapes, and spatial relationships, which helps us make sense of the world around us.
So it's like a stepping stone.
Yeah.
Between the flat image hitting our retinas and actually understanding the 3D world.
Precisely.
Okay.
And here's where it gets really interesting.
Okay.
In relation to AI.
Okay.
Think about modern deep learning systems, like facial recognition.
Right.
They work in layers, too.
Yeah.
Building up more complex understanding as they go. Kind of like Marr's 2.5D sketch.
Oh, wow.
He was way ahead of his time.
So Marr's work on how we see could be a key to understanding how AI sees the world, too.
Absolutely.
That's amazing.
It's fascinating.
But it sounds like his legacy extends far beyond just vision.
Oh, absolutely.
Right.
Yeah, like where else?
Marr's framework is incredibly relevant to some of the biggest challenges and debates in AI today.
Like what? Well, one example is the issue of explainability.
Okay.
We're building these powerful AI systems, but often we don't fully understand how they're making decisions.
Right. It's like a black box.
It's a bit like a black box, yeah.
Yeah. And that can be a problem.
And that can be a big problem, especially when these systems are being used for things like medical diagnoses or driving cars.
Yeah, we need to know why an AI is making a decision, not just that it's making it.
Exactly.
Right.
And this is where Marr's levels come in.
Okay.
He reminds us that to truly grasp AI, we need to understand not just its actions, but also its goals.
Right.
And processes.
Okay.
The computational and algorithmic levels.
So it's about making that black box more transparent.
Exactly.
So applying Marr's framework could be a way to design AI systems that are not only powerful,
yes,
but also understandable.
Understandable.
And trustworthy.
And trustworthy, exactly.
Okay, so where else?
So another area where Marr's influence is evident is in deep learning. Those layered neural networks.
Right.
We hear so much about these days.
Yeah.
They have direct roots in his ideas.
Okay.
About hierarchical processing. Breaking down complex tasks into simpler, interconnected layers.
So from facial recognition to self-driving cars, this guy who was working decades ago,
I know,
is basically laying the foundation for the AI revolution happening right now.
It's incredible.
It's incredible to think about.
To think about the ripple effect of his work.
The ripple effect of his work, yeah.
It truly is.
Okay, so let's talk about the future of AI.
Okay.
The ultimate goal of many researchers is AGI, or Artificial General Intelligence.
Yes.
Which is AI that is as smart and adaptable as humans.
That's the big one.
That's a big one.
Yeah.
So how does Marr's work connect to that ambitious goal?
Well, if we want to build truly intelligent systems, we need a framework for understanding intelligence itself.
Okay.
And that's exactly what Marr provides.
Okay.
His emphasis on goals, processes, and implementation gives us a roadmap for thinking about how to design AI that goes beyond just raw processing power.
So it's not just about building bigger, faster computers. It's about understanding.
It's about understanding the fundamental principles of intelligence itself.
Wow, that's powerful.
Yeah.
And so while Marr's work has been incredibly influential, it hasn't been without its critics, right?
Oh, of course, of course.
Like, what are some of the criticisms of his work?
So some argue that his framework is too focused on goals and functions.
Okay.
That it doesn't quite capture the complexity and sometimes messiness of real biological systems.
Well, like the brain isn't always this perfectly rational machine.
Right.
It's influenced by emotions, instincts, things that are harder to model.
Exactly. Yeah. And another question that comes up is, can AI truly be intelligent if it doesn't have a body and experiences like we do?
That's a good question.
You know, this gets into the idea of embodied cognition, which suggests that our minds are shaped by our physical interactions with the world.
That's fascinating.
It is a fascinating question.
Yeah, it makes you wonder if intelligence is something that can exist solely in a disembodied computer.
Right.
Or if it requires a physical presence in the world.
It's a question worth pondering, for sure. But even with these criticisms, it's undeniable that Marr's work has sparked vital conversations. And continues to influence how we think about both biological and artificial intelligence.
Okay.
It's a testament to the enduring power of his ideas.
Wow. So we've covered a lot of ground here.
We have.
But I think there's still a lot more to explore when it comes to Marr's ideas and their impact on AI today.
Yeah, absolutely.
It's amazing how Marr's work seems to bridge this gap between artificial intelligence and cognitive science.
Absolutely.
These two fields that are both trying to understand intelligence, but from different angles.
Yeah, Marr's ideas actually emerged at a time when cognitive psychology was gaining a lot of momentum.
Okay, and so for people who might not be familiar, what's cognitive psychology all about?
So it focuses on understanding the mind as an information processor.
So moving away from just observing behavior and trying to actually understand the mental processes happening inside the brain.
Precisely, yeah.
Okay.
And Marr's framework offered a new way to approach this.
Okay.
His computational level, which focuses on the goals of a system. Aligned perfectly with what cognitive psychologists were trying to do.
So both fields are trying to understand the why behind our thoughts and actions.
Exactly.
What are we trying to achieve with our minds?
Exactly.
Okay.
And then you have Marr's algorithmic level, which provided a way to actually describe the processes and representations that the mind might be using to achieve those goals.
It's almost like he gave cognitive psychologists a new language to describe the mind?
Yeah.
A language that was borrowed from the world of computer science?
Absolutely, yeah.
Did that have a big impact on the field?
Oh, absolutely. It led to a surge of research in computational neuroscience.
Okay.
Which uses computational models to understand how the brain works.
So instead of just speculating about what might be going on inside the brain, cognitive scientists could actually start building and testing models just like AI researchers.
Exactly. It was a game changer.
Wow.
And Marr's impact extended even further into the realm of philosophy.
Oh, okay. Like what kind of questions?
Well, his work touches on the debate between two different approaches to AI. Symbolic AI and connectionist AI.
Okay.
So symbolic AI, which was the dominant approach back in Marr's time, relied on explicit rules and logic to try and model intelligence.
So kind of like programming a computer with a set of if-then rules
exactly.
to try and mimic human reasoning.
Exactly.
Right?
But Marr's framework, particularly his emphasis on representations and hierarchical processing, paved the way for connectionist approaches like the neural networks that are so popular today.
And neural networks are all about learning from data and patterns, right?
Exactly.
Rather than following these explicit rules.
Yeah.
So even though Marr himself was more aligned with symbolic AI, his work helped to bring about the rise of connectionism.
It's a bit of an irony, but yes.
That's incredible.
It's like he planted a seed that grew into something even bigger than he could have imagined.
Wow. Did his work raise any other philosophical questions?
Definitely. It also touches on the nature of consciousness and representation.
Okay.
Marr believed that understanding how the brain represents information was key to understanding how it works.
Like those 2.5D sketches we talked about, the brain is building these internal representations of the world to make sense of it all.
Exactly.
Okay, so...
And that raises a question.
Yeah.
If AI systems can create similar representations, does that mean they could also be conscious?
Whoa, that's a deep one.
It is. And while Marr himself didn't explicitly address consciousness, his work lays the groundwork for these kinds of questions. It challenges us to think about what it really means to be intelligent, whether you're a biological brain or a sophisticated machine.
So it's about more than just building better AI systems. It's about grappling with these fundamental questions about the nature of intelligence itself.
Precisely. But of course, like any groundbreaking work, Marr's framework has also faced some criticisms.
Oh, of course.
So some philosophers argue that it's too focused on goals and functions.
Okay.
That it oversimplifies the complexity of real biological systems.
Like we were saying before, the brain isn't always perfectly rational.
Right.
It's influenced by all sorts of factors that are harder to neatly define.
Exactly. Yeah. And another criticism relates to the idea of embodied cognition, which we touched on earlier.
Right.
Marr's framework is very abstract, focusing on the computations inside the brain.
Okay.
It doesn't fully consider the role of the body in the environment in shaping our minds.
So some would argue that you can't fully understand intelligence without considering how it's grounded in the physical world.
Exactly.
In our interactions with our surroundings.
Exactly. And you also have to consider the limitations of the time when Marr was working.
Right.
Computational resources were much more limited back then.
Of course.
So his models and theories weren't necessarily simplified.
He couldn't have anticipated the rise of deep learning and the sheer amount of data and computing power that these systems require.
His focus was more on designing elegant algorithms.
Okay.
While deep learning is more about letting the data guide the learning process.
Interesting.
And this actually leads to another challenge that Marr's framework might struggle with: explainability.
Because even though he emphasized understanding those intermediate representations, deep learning models are often quite opaque.
Right.
It's hard to know what's going on inside those layers of artificial neurons.
Precisely. So while Marr's framework gives us a fantastic foundation for thinking about intelligence, it also needs to be adapted and extended to account for the advancements and challenges of modern AI.
It's like he provided the blueprint for a building, but now we need to keep adding new floors.
That's a great analogy.
As AI evolves.
Yeah, and that's what makes this field so exciting.
Yeah.
We're constantly pushing the boundaries of what's possible.
Right.
And Marr's ideas continue to inspire and guide us.
It sounds like even with the criticisms, Marr's legacy is undeniable.
Absolutely.
He shaped how we think about vision intelligence. And the relationship between brains and machines.
Absolutely. And his work remains deeply relevant today.
Yeah.
As we wrestle with the opportunities and challenges of artificial intelligence.
It's incredible to think that someone who died so young, back in 1980, is still having such a profound impact.
It's incredible.
On one of the most important technological revolutions of our time.
It speaks to the power of his ideas. His ability to see beyond the limitations of his time.
Right.
And envision a future where brains and machines could work together to understand the mysteries of intelligence.
It's fascinating to think about all this in theory, you know, these ideas of Marr's.
Yeah.
But I'm curious to see, like, how this all plays out in the real world.
Right.
Like, how are his ideas actually shaping the landscape of AI today?
Well, one of the most striking examples is in the field of computer vision.
Okay.
We talked about Marr's work on vision, his 2.5D sketch.
Right.
And how that laid the groundwork for hierarchical processing in AI.
And now computer vision systems are everywhere, right?
Oh, absolutely.
From facial recognition on our phones to self-driving cars.
Everywhere, yeah.
Navigating our streets.
It's remarkable how far the technology has come.
It really is.
And it's all built on those foundational principles that Marr laid out decades ago.
It's mind-boggling to think that he was already thinking about this stuff back in the 70s and 80s.
I know, the idea of breaking down a complex visual scene into layers, from edges and textures to shapes and objects.
Yeah.
That's pure Marr.
Wow. And these systems aren't just replicating human vision.
No, they're not.
They're actually surpassing it in some ways.
Oh, absolutely. Think about AI systems that can detect tiny details in medical images.
Right.
Or identify patterns in massive data sets.
Right. Things that would be impossible.
That would be impossible for humans to process.
That's us to see.
Exactly. And this is where Marr's influence goes beyond just the technical side of things.
Okay.
He really emphasized the importance of understanding the computational goals of a system.
Right.
The why behind the how.
So in the case of computer vision,
yes,
that means understanding what we want these systems to do.
Exactly.
Whether it's helping doctors diagnose diseases more accurately or making our roads safer with self-driving cars.
Right.
It's about using these incredible tools for good.
It is. Marr's framework helps us to think critically about how we design and deploy these systems.
Yeah.
It's not just about the technology itself, it's about the purpose behind it.
It's like he's reminding us that with great power comes great responsibility, even when it comes to AI.
I like that.
Right.
And Marr's influence extends beyond just vision, too.
Okay. Where else?
We're seeing a similar revolution happening in natural language processing.
Right.
The field that deals with understanding and generating human language.
We talked about how Marr's work kind of helped to pave the way.
It did, yeah.
For these connectionist approaches like neural networks, even though he himself was more aligned with symbolic AI.
Exactly.
And now those neural networks are at the heart of some of the most impressive language AI systems out there.
I know, it's amazing.
Like ChatGPT.
Yeah, GPT, yeah.
Which can generate human quality text.
I know.
And hold these nuanced conversations.
Yeah.
They're built on these massive neural networks that learn from just enormous amounts of data.
Amazing amounts of data.
It's almost like they're taking Marr's ideas and running with them, even if they're not consciously doing so.
Right.
What do you think?
That's a great question.
Are AI researchers today directly influenced by Marr's work, or is it more of an unconscious influence?
I think it's probably a bit of both. You know? Marr's ideas have become so fundamental to how we think about intelligence.
Right.
That they've almost become part of the air we breathe in this field.
Yeah.
But I also think there are many researchers who are very consciously drawing on his work.
Okay.
Especially when it comes to things like explainability and the quest for artificial general intelligence.
Right, because as these language AI systems get more powerful,
yes,
it becomes even more important to understand how they're making decisions.
It does.
Especially when they're generating text that could have a real impact on the world.
Absolutely. Language is powerful.
It is.
It can be used to inform, to persuade, to manipulate even.
Right.
So we need to be thoughtful about how we use these new language tools.
It's like anything else. It can be used for good or for bad.
Exactly.
We need to be mindful of that.
We do.
And that brings us to what is perhaps the most ambitious goal in the field of AI, creating artificial general intelligence, or AGI.
The holy grail of AI.
A holy grail, a system that can truly think and learn like a human. Do you think we'll ever get there?
It's hard to say for sure.
Yeah.
But what I do know is that Marr's ideas are absolutely essential to this quest.
Oh.
His holistic framework, his emphasis on understanding the goals and principles of intelligence.
Right.
That's the roadmap for building truly intelligent systems.
So it's not just about raw computational power.
No, it's not.
It's about purpose, understanding.
It is.
And the ability to learn and adapt like a human does.
Precisely.
Yeah.
And I think Marr's work also reminds us that intelligence isn't just about solving problems in isolation.
Right.
It's about interacting with the world, learning from experiences,
right,
and using those experiences to inform future actions.
It's about being embedded in the world, not just observing it from a detached computational standpoint.
Exactly. And even if we never achieve true AGI, I think Marr's legacy will live on in the systems we build and the way we think about intelligence.
Right.
His work has shifted our perspective in such a profound way.
It's amazing to think that one person who tragically died so young could have such a lasting impact on such a complex field.
I agree. David Marr was a visionary who helped us to see that intelligence in all its forms is not some mystical force, but a process that can be understood, modeled, and perhaps even replicated.
And that's a powerful idea.
Very powerful.
Well, this has been an incredible deep dive.
It has been,
Thank you so much for sharing your expertise and insights with us.
My pleasure.
And to our listeners, thank you for joining us on this journey into the remarkable world of David Marr.
Yes, thank you.
I hope you've enjoyed it and maybe even learned a thing or two about this fascinating intersection of neuroscience, AI, and the human mind.
Absolutely.
Until next time, keep exploring, keep questioning, and keep diving deep.